Saxon's Trig, lesson 35, page 249, is about change in coordinates, the name of a number, and then the distance formula. Part A, change in a coordinate. If we have two dots, and I am definitely moving from this dot through this dot, and we call this point 1 and this one point 2, I am saying that I'm moving from point 1 through point 2 or to point 2. If I go the other direction, I would be indicating I'm going from point 2 to or through point 1. So the direction matters. And I am looking for what they call the directed distance. And it's easiest if I just jump into example 1. So given that point 1 is -3, 2, and point 2 is -4, -5, what do we represent by, and then for question A, it says -3 minus -4. So this is supposed to be my first going through to my, wait, am I saying that backwards? Moving from 2 to 1. Yes, I am starting to say that backwards. The first number here is going to be my point that I'm heading through, because what I'm saying is I want to have my second one minus my start one. So since my minus is here, this is the one that I'm ending with or going through, and this is the one that I'm starting with. So where did the point 4 come from? Point 2. So this is point 2 to point 1. That's what we're looking for A. Make sure that's right. P2 to P1. Yes, okay. Now in part B, it asks for -5 minus -2. Okay, so again, this is my starting point. This is my through point. Where did the 5 come from? Point 2. So I'm starting with point 1 to point 2. That's the direction that that is going. Okay, so they can ask you questions like that. Now let's do the same thing again with example 2 on page 250. If the coordinates of P1 are -3, -2, and P2 is -4, -5, is that the same? No, that one has a negative. They changed it only so slightly. What do we represent by A, -4 minus -3? So again, this is my starting place. So where is the -3 coming from? P1. So it's P1 to P2. And in B, it asks for -2 minus -5. This is my starting number. Where did -5 come from? P2 to P1. So once you have the pattern established and you know that the second one is actually your starting dot, then it's easy to write the pattern. Part B talks about the name of a number. And it basically is just talking about where does a number land. So in example 3, it says, what is the number whose graph is 7/3 of the way from 3 to -7? Now, just to get a visual of what's happening here, let's put our 0 here. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. There's my -7. That spacing's a little off. I tried to end with the line and didn't give it quite enough space. So I'm looking for the full distance between 3 and -7. And because one is in the negatives and one is in the positives, I can just count. I can count all of those jumps and get 10. Or I can say I've got 7 up to here and 3 up to here. 7 plus 3 is 10. Either way, my distance is a distance of 10. And the problem is telling me I only want to travel 2/3 of that distance. So we're going to multiply 2/3 by that 10 to find our full distance. So that would be nothing to reduce, 20/3. So I'm moving 20/3. The question becomes, am I moving 20/3 from the 3 or from the -7? Okay, just 1 second here. We were asking the question, should we move this distance from the -7 or the 3? And the key here is it is always from the first given number. And this is kind of why we talked about 0.1, 0.2 up here, because this first one is your starting one, and that's the one you want to adjust the distance off of. So we need to move it 3 minusing, because it needs to be between these values. So I want my place to be 20/3 off of the 3. So 3 minus 20/3. This needs a common denominator, makes it 9. So -11/3 is the actual place, and that would be like -3, -9. Yes. So that's like moving it, here. Approximately somewhere in here would be that -11/3. And that would be that short little 2/3 of the distance. Now, I want to pause and go back to something that was bolded in section A that I did not talk about. When we were finding these from point 1 to point 2, I hope that you noticed that your -5 was the y value, and it matched with the y value. So the clarification here would be, I'm going from point 1 to point 2 with the y coordinates. Or this one where I went point 1 to point 2, it was -4 and -3. These are my x values. So I'm moving from point 1 to point 2. That's a change in the x values. This is a change to the y values. Now, I stop to clarify that because I did this on the number line to show you basically what you were, oh, you know what? That's why that didn't feel right. Negative, oh my stars. Let me write that. -3, because that's 9, and 2/3. That would be 1, 2, 3, and a little more. That makes a little more sense, because if I mentally picture this whole distance of 10 split into 3 parts, and I want 2 of those parts, it should be way closer, because this should only be 1/3 of the distance left to finish that off. Yes, that does make sense on the number line. Okay, so we were working this problem on the number line, but I don't want to have to do that each and every time. I want a formula that basically gives to me what I need to do. So the pattern would be this. Take your, this is going to be 0.1, this is going to be 0.2, because I'm going from 3 to 0.7. So you want to take whatever the fraction is, multiply it by 0.2 minus 0.1, and then add to 0.1. And that's the formula that you basically want to follow. So in example 4, if I don't do the number line, it asks for 3/7 as the fraction from -4 to 9. So I'm going to do 9 minus, what did it give me? -4 minus -4. Okay, so at that point I realized I should have changed that because I'm using the parenthesis here, plus, and 0.1 was -4. So all I have to do is the algebra, which is much faster than trying to draw the number line, but you needed that to kind of understand what this is doing. So 3/7, I can go back to a parenthesis now, 9 plus 4 is 13, plus -4, might still want to keep that in a parenthesis, and that would be 39/7 minus 4, I'll just write it that way. Need a common denominator of 7, so 20, oh goodness gracious. Why am I having trouble with my 7 times 4?